Okay, so continuing on, we figured out the number of neutrons is 7 for carbon. Now we just have to write the element symbol. So once again, we look at the mass number that goes on top, and the atomic number goes on bottom. Now we need to figure out if this thing is charged. The protons and electrons are equal, 6 and 6. So that means this is a neutral atom. So we don't have to write a charge up there. Okay. Lastly, we're going to take everything that we just learned and kind of flip it around, because now I'm giving you all this information compacted into the element symbol. So we know that this is aluminum. Okay. This is the atomic number on bottom. The atomic number is the same thing as the number of protons. Okay. On top is the mass number. The mass number is the same thing as the number of protons plus neutrons. So 27 minus 13, that gives you 14 neutrons. We also know that this is aluminum. Okay, the number of electrons and protons, we got to figure that out. Those two kind of go together. So we got to look at the charge here. Aluminum has a 3+ charge. It has 13 protons. So there's going to be 3 more positive charges than there are negative. Okay, so if there's 13 positives, we have to have 3 more positives than negatives, so we have 10 electrons. And that kind of completes that type of problem. The last concept that we learned in Unit 3 was figuring out the average atomic mass of an element. So we need to figure out the average atomic mass of different elements, because different elements have different isotopes. So in this problem, we're determining the average atomic mass of lithium. There's a lithium-7 isotope and a lithium-6 isotope. So what this means is lithium-7 is a mass number of 7. Lithium-6 has 1 less neutron, so it has a mass number of 6. It's lighter. It's 1 atomic mass unit lighter. So we need to take the weighted average of these 2 isotopes. We need to figure out between these 2 isotopes what is the average atomic mass of this element, because we want to have a consistent average value that we use for calculations. So we're going to find the weighted average. Because these things exist in different proportions on the Earth, we have to use what is called a weighted average, where we use the percentage of each isotope in order to find the average. We can't just add them up and divide by 2. Okay, so take your lithium-7 ion. To find the contributed mass from lithium-7, take the number 7, multiply it by the percentage abundance. Remember, a percentage is, and when we use it to calculate things, we have to move the decimal place over 2 places. Okay, you're going to get a calculation there. Do the same thing for lithium-6. Take your mass, multiply it by the percentage. Okay, and you're going to add whatever these 2 values are. You're going to add them together. Okay, so when you multiply 7 times 0.97, you should get 6.79, and then 6 times 0.03, 0.18. Add those 2 together, 6.97, and the unit is AMU, average atomic mass unit.